Hello and welcome back to Global Math Mentor. Another lesson on complex numbers, and this time I'll be guiding you how to switch between forms of complex number. So this lesson is very useful for pure mathematics 3 A levels and IB HLAA math as well. So let's talk about the first form that I discussed in my earlier lessons. That was A plus IB, which is iota. So if a complex number is written in this form is known as the rectangular form. Rectangular form. Also, there's another name you can use, the Cartesian form. Cartesian form, which is the most common form that we come across on complex numbers. But it's not like this is the only way of representing complex numbers. There are other forms, and they are also useful. I'll explain in the later lessons how sometimes the exponential form is very important, and sometimes the Cartesian form is very important, and sometimes, obviously, the polar form is very important. So let's talk about the polar and the exponential forms. Exponential forms. How do you write a polar form? I'll write the general form of a polar form. It's known as r cos theta plus iota sine theta. So this is usually what you'll come across in your A-level math. But sometimes in elsewhere, like the HL mathematics, it's written as the cis form as well. So don't get confused if you see cis somewhere. This means cos iota sine. I know for the beginners, it sounds completely strange why a polar form is like this and the Cartesian form is like that. But I'll get back to that. And the exponential form on the other side is written as r e iota theta, which is the Euler form as well. Sometimes we call it the uh, Euler form. But mark my words, the A-level mathematics only use the exponential form, the term, and the polar. So the IB HL use the cis and sometimes call this the Euler form as well. So don't get confused. Even if you're studying any course, getting to the right concept is important. And the names may differ, but the idea is the same, right? Okay, let's dive into it. So now we know there is a rectangular form, also called Cartesian form, the polar form r bracket cos theta plus iota sine theta, and the exponential form, which is written as r e iota theta. Naturally, the question arises, what is r and what is theta? Well, r is just the modulus, and theta is the argument of this complex number. If you do not know how to calculate the modulus and the argument, there's a detailed lesson on that. I'll share the link in the description. You can watch that video because that's the fundamental concept, how to get the modulus and argument. So in order to master it, I'll take an example, a Cartesian form. Z is 1 plus root 3i. And I'll show you how to convert it into the polar and the exponential form. Okay? So let's get the value of r, which is z modulus, real part squared, which is 1, and the imaginary part squared, which is root 3 squared. So this becomes 1 plus 3, which is root 4, and that is a 2. Okay? I'm going to sketch it on an Argand diagram in order to calculate the argument. What is argument? It's the clockwise or anti-clockwise angle with the positive real axis. Okay? So let's sketch the complex number. It's the first quadrant, so positive 1 and a root 3. Okay? This is 1, root 3. Any point on the Argand diagram is just a complex number where the x-coordinate is the real part and y-coordinate is the imaginary part. This is 1, this is root 3. How do you get this angle? So tan inverse of a root 3 divide 1. I'm using TOA from the SOHCAHTOA. So that's going to be, that's a special triangle value. So tan inverse root 3, you can check your calculator, is going to be 60 degrees or the pi over 3 radians. So if not stated, the angle should be given in radian. Okay, so pi over 3 radian is the argument, and this is the modulus. Let's write the polar form. So the polar form of this complex number can be written as this one, 1 plus root 3 iota is 2 cos pi over 3 plus iota sine pi over 3. And the exponential or the Euler form of this complex number is written as 1 plus root 3 iota. This same complex number can also be written as 2e iota pi over 3. So make sure you take notes on this and save it somewhere because this is going to be useful in the later work. Let's solve some questions together. If you want to try it on your own, pause the video and give it a go. Come back and check my work later. Okay, so let's call it W. I can suppose it anything Z, U, V, W. Usually we take these alphabets for the complex numbers. So I need to write this form, which is a polar form, and theta is within 0 to 2 pi. Let's calculate R first, which is the modulus of W. The real part is a root 2, negative root 2, square it, and add it to the imaginary part square, which is the negative 1 square. Root 2 square is a 2, negative square is a positive. It's going to be 2 plus 1, root 3. I need to calculate the argument. Always check the quadrant. Remember, real, imaginary, both real and imaginary parts are negative. It's going to be the third quadrant. Okay? It's a root 2, and that's a 1. I need to calculate this angle, which is not an exact value. Tan inverse a 1 over root 2. So I need to use my calculator to calculate this value. Let's do tan inverse a 1 divide a root 2. So this is going to be, it's taking some time. Okay. So 0.615479 dot dot dot. Let's take let's say for simplicity's sake, 4 significant value. Okay, so 0.6155, 0.6155. Since it's not the first quadrant, so my domain says it's 0 to 2 pi, so I can only go with the positive value for the argument. So I'm going anti-clockwise. So it's going to be pi plus a 0.6155. So take your calculator value and just add a pi to it, right? It's going to be 3.757. So 3.757. So let's take a 3 significant radian value. So that is my argument. Let's write the polar form. So the answer is going to be R, which is root 3, cosine of a 3.76 plus iota sine of a 3.76. Put a bracket over here, and that's my answer, right? Let's look at another problem. Convert to rectangular form. So this time they have given a complex number in polar form, and I need to convert it back to the rectangular or the Cartesian form. Okay. So how do we do this? You can use a calculator as well to calculate these values, but remember these are special values. So I know that cosine pi over 3, which is a 60 degree, is a half. So this is 120. So cosine 2 pi over 3 is going to be a negative 1/2. And sine is the same for the obtuse and the acute values. So sine pi over 3 is a root 3 over 2. Same is the value for 2 pi over 3, but still you can check them with the calculator. So this is going to be 8, a negative 1 over 2 plus iota, a root 3 over 2. Let's simplify this. It's going to be a negative 4 plus a 4 root 3i. And that is it. So have you checked, like, it's simpler to write a polar or the exponential form back to Cartesian form, but when you're converting from the rectangular form to the polar and the exponential, so you need those calculations with the modulus and the argument, right? Okay, so another example, convert to exponential form 2 minus 2 iota. I need to write it. Let's call it u. And u mod, which is r, is going to be 2 squared plus a negative 2 squared. Okay, it's going to be 4 plus 4, which is a 8. You can give 8 or a 2 root 2. It's up to you. Okay, so now I need the argument. This is the fourth quadrant. The real part is a positive 2. The imaginary part is a negative 2. Okay, so it's going to be here somewhere. And the angle is again an exact value. Tan inverse, a 2 divide 2 is a tan inverse 1, which is a pi over 4. But stop and think. You can either go anti-clockwise, since no domain is given, or you can go clockwise. Let's take a clockwise value. So the actual value of the argument, which is theta, is going to be a negative pi over 4 since it's the clockwise direction. So how do you write your answer? You can write it 2 root 2 and e iota, a negative pi over 4. If you don't want to write it in bracket form, just write, or I'm just giving different variations to the same answer. You can write root 8e, a negative pi over 4 iota, right? So, well, you see, this was a useful lesson where we learned how to convert between different forms of complex number. Stay tuned for more useful lessons and hit that like button and subscribe to my channel. Over and out.